My name is, for some of you that don't know about our company or myself, my name is Jeff Cote and I'm with Pacific Yacht Systems. I'm an owner-operator of the business. And some of you here know about a little bit about us. But basically, I'm here up front sharing really my collective experience of working with only one purpose, which is marine electrical on boats. That's what we do. And last year, I'm pretty proud of this, we worked on 750 boats doing electrical systems. So what that means for you as a boat owner is the more we work on boats, the better we understand them. And there's a lot of ways of doing things on a boat, but there's always maybe a better way of doing something on a boat, a common way that makes it easier for everyone. And what I'm going to try to share with you today is lessons learned of seeing all of our boats out there and the pitfalls that happen with some of us, and making sure that you avoid making the mistakes that other boaters have done, so that you can get to where you want to go, but without making too many mistakes or getting there efficiently. The other big thing, especially when you're talking about electrical, I want to emphasize, it's sort of like being an accountant. You move a decimal point to the right or to the left. Doesn't sound like a lot, but let me tell you, with electricity, just simply one wire miswired. Electricity, it's not about doing 100 good crimps and, oh, I just got one wrong. Every single crimp has to be great. So there's no excuses when you do electrical that it's good enough. One bad connection is the only connection that you need for having potentially fire on board your boat. So sort of like being an accountant, if you don't care where the decimal points go, you're not going to be an accountant. If you're not a perfectionist, then you probably shouldn't touch your electrical. I mean, that's what it is. I mean, I have clients that have no technical background that are amazing at the electrical systems that they do. The most dangerous part about doing work on electrical on a boat is think that you know everything and that you're just going to do it. You know, the MacGyver instinct. There's no room for that, not on a boat, not for electrical. Right? Remember, it's not a barn, it's not in the backyard. When it catches on fire, it's your home, your family's asleep. You can't run away from a boat, you have to swim out, you have to jump over, there's generally only one exit. There's a lot of reasons why you want to make sure that when you do work electrically on your boat, and I encourage a lot of owners to work on their boat, you get to know it better, but do it properly. Do it slowly, do it safely. Don't be gung-ho about it. So follow the standards. All right, so a little bit what we're going to be talking about. We've got a lot of stuff. Talking about a little bit about background. We're going to talk about how to figure out what do you need. A lot of people come to us and say, how much batteries do I need? Well, that's not the first question, right? There's other questions that come ahead of that, so we'll talk about that. Figuring out where do you go about, now that you know what you need, what is the bank that you need? How do we then recharge that battery bank aboard your boat? Because it's one thing for owners to get a larger and larger battery bank. That's like having a bank account that allows you to store more cash. It's a great thing to be allowed to store cash, but where are you going to find the energy to resupply that battery bank? That's the real challenge. Right? For a lot of boaters, especially if you leave the dock for one night, BC Hydro can recharge your boat via a charger, go out at night and you come back. That's easy. It's going out for extended periods of time, going for 2 nights, 3 nights, a week, 2 weeks, 3 weeks, a month. Where do you find the energy to recharge that battery bank at the right rate so that you're not constantly going in a deficit? And so we'll talk about all the different sorts of charging methods that you have nowadays on a boat to recharge your battery banks. So first and foremost, and I alluded to this, and I cannot emphasize that enough, there is no room on a boat with electrical systems with being a sort of MacGyver. Getting it done is not good enough. So if you're going to work on your boat electrically, remember you might be willing to take chances on your boat, but everyone that assumes that come aboard your boat, they assume that it's like everything else in their lives and it's built to code and it's built to a certain minimum in terms of safety. They don't realize that you can do whatever you want on your boat. Nobody's going to enforce anything. Maybe your insurance is going to be doing it, but other than that, it's you do what you feel you want to do. So the really crazy part of that is that you might bring friends or family, and they're going to assume that your boat is like a car. People have given thought to it, and they want to make it safe, and they don't want it to be a Pinto. So when you take those chances, be aware that when you're inviting other people on your boat, they don't know the risks that you're willing to take, and they're probably not comfortable with what some boaters are doing on their boat. Some people luckily for them, they're just not worried about dying or fires, and for them it's easy because the job gets done a lot easier. But with electrical, most of us care about those things, and it's really important to do your boat properly. The other thing I want to emphasize on this slide really quickly is that there is no single boat that is a perfect boat. There is no amount of money, there is no amount of anything in the world that makes a perfect boat. Regardless of your budget, everything is about a compromise. We've worked on boats where it was a $35 million refit, and there's no money on that budget, but it's constantly choices. Everything's a choice. You're going to do that or this. And when you're going to be looking at designing or thinking about how you design your electrical system on your boat for you, don't be too tempted to look at what your neighbor's doing on the identical boat. You might have a Monero. You might have could be anything. It could be a Grand Banks, a Catalina. I have a Catalina. It could be a Bayliner. Two identical boats over the course of their lives are going to go on their different paths electrically because owners have different needs. Some people stay at the dock all the time. Some people go only for one night at an anchorage. Some people go out for 3 weeks, a month. Some people go up to Alaska. All those different types of usage are going to actually affect the electrical system on the boat. And so you want to always think about, okay, what are you doing and why? Not as what did you do and I want to do what you did. You want to understand the requirements, and then you might want to copy what they did to get to that solution that you think you need to do. Remember this. If I would ask a show of hands in the room and I would say, how many people think here they use a lot of power? There'd be a lot of hands that wouldn't raise. Most boaters think they don't use a lot of power. But the moment you have refrigeration on board your boat, it's sort of like a Vancouver mortgage. There's no other way around it. 80% of your income, of your power, is going to be to refrigeration. That's what it is. And don't think that you've got a bigger boat that proportionally your refrigeration is smaller. No, you have more refrigerators. The refrigerators are simply bigger. You have many of them. They're in multiple locations. So refrigeration is the #1 consumption of power on a boat. If you don't have refrigeration on your boat, you are truly a Luddite. Other than that, you've got power problems. And anyone, I remember I was in boating back then, but I was dreaming about boating when I was 4. People tell me, oh, Jeff, prior to me doing a icebox conversion on my boat, I had lots of power. The moment I put an icebox conversion and I converted my little icebox to refrigeration, now I don't have power. And it's the same thing, all those big fridges, it could be a 60-footer, it could be an 80-footer, I have a 36-footer. At the end of the day, refrigeration is an absolute killer for power. So if you can do without refrigeration, most of this, what I'm going to talk to you about today, you're going to be like, I don't need it, I don't have to worry, I got a small budget, I don't have problems. But if you have refrigeration on your boat, unfortunately, you're always fighting to find a way to run that fridge. That's really what it comes down to. So there are large loads that are deceiving on a boat. People think that, for example, a diesel heater does not draw electricity. Diesel heaters might take their heat from diesel, but the propagation of that heat is actually through fans. And the fans don't run through power from the diesel, they run through fans from your battery. So a diesel heater would not run and would be useless on a boat without a battery. On my boat in the wintertime, I was on 2 weeks in the Gulf Islands. My heater was drawing anywhere between 7 and 12 amps when it was on a 36-foot boat. Now, it's always a function of how cold it is, but a heater, even a forced air heater, is going to draw 3, 4, 5, 6 amps. It's going to be as much as refrigeration when you need it. So in the wintertime, and that's the point, is it really depends what type of boating you do. If you boat in the summer when it's light from 5:30 a.m. to 10 a.m. in Desolation Sound for 2 weeks, you're not going to have that many draws, right? Your lights are never going to be on. Maybe your anchor light will, but pretty much it's sunlight all day. At one point you have to sleep. And you're not going to be running the heat. So you're going to have a lot less loads in the summer than you would in the fall or spring or in the wintertime. So think about what type of boating you do. I'm all year round boater. Some people are just the summer, they use it for 1 month or 2 months, and some others use the extended cruising season. Or if you go up north and you pass Desolation Sound and you hit the Discovery Islands, well there it's eternal, never summer, eternal spring or fall, right, as you go up the coast. Right? It never gets too hot, so you always want to maybe have a little bit of heat. And those factors are going to come into deciding your daily power requirements on your boat. And I say power, it's sort of like when someone asks you, how much money do you need to retire? Well, that's a function of what is going to be your yearly consumption, how much money you're going to spend in a year. Really, you don't decide how much you save. You decide how much do I need to live in a year? and then you figure out how much money you need to live for that period of time. Power is exactly the same thing. So to give you an idea and to quantify the sort of number, because I mean, we can all probably imagine what is $100,000 or $50,000 a year. It's relatable to most of us. Power on a boat is measured not in dollars, but in a unit called an amp hour. Not an amp. An amp is the rate at which you use something. It's sort of like a speedometer. Kilometers per hour. Okay, that's an amp. Amp hour, it's misleading because an amp is coulombs per second. An amp hour is a distinct unit. It's sort of like a kilometer, a meter, a kilogram. It's a thing. It's a unit. So you might, or a dollar. So on a boat, for example, I have a Alternator 36. You might have, your budget might be 150 amp hours. On a Meridian 580, which is sort of like a more expensive version of a Bayliner 5788, most of the owners are going to be around 400 to 600 amp hours, right? So that gives you an idea. You're going to have a Grand Banks owner 175 amp hours. Now it's going to vary. We do a lot of work on Grand Banks. I've probably worked on, 42s, maybe 50, 60, 70. Not every owner is the same. Some owner has a deep freeze on the flybridge. Some owner doesn't. Some owner watches TV. Some owner doesn't have a TV, right? So again, it's really tempting to simply want to mimic or copy what the neighbor is doing in the identical boat, but unfortunately they might not be behaving or doing the same things you're doing. So you might have the same boat, same year, but you're using twice the power of your neighbor. So you got to figure out what is your daily amp hour consumption. If you don't know what that number is, and there is a way to do that, which is with a battery monitor, which counts sort of like having an accountant in your business that tells you the state of health of your business constantly, every day. A battery monitor will quantify both the amps coming in and out of your batteries, the speed at which you're burning power or saving power, and then it's also going to tell you the capacity of your battery, like a fuel gauge. Am I at 70% of capacity? Am I at 50% of capacity? And then you can start making your calculations. If you know what your burn rate is, right? Like, I travel, I spend $100 a day when I'm traveling. Well, and I've got $1,000. Well, I can last $100 a day for 10 days, will give me the duration of my trip. So once you know what your daily burn rate of power is, you'll know what your battery capacity is right now, and you'll figure out, oh my God, I can only last half a day. I only last a day. I want to last 3 days at anchor, right? And so that's the next step, which is figuring out what is your usable battery capacity. And there's a big distinction between what you see and what you have. Batteries, and we'll talk about that later, should not be depleted all the way to zero. Sort of like a human can probably do superhuman feats of strength, but that will have a detrimental effect to their health. A human might be able to run 3 marathons in a row to save their family or whatever, but that person will not be the same at the end of that run. They will be forever changed. If you take your lead acid batteries and you go from 100% to zero, you're only going to be able to do that 50 times. And these are the boat owners that complain that their batteries don't last and they wonder how unlucky they are and things aren't going their way. But they're working those batteries so hard that the batteries are not giving them a reasonable life expectancy. That means they have too small batteries for what they're trying to do. So the point that what I'm saying is once you know what your daily consumption is, you have to figure how long are you going to go without running or finding some way of recharging those batteries. Some of us that have generators might be willing to run the generator twice a day. Pretty common, morning and evening. Twice a day, so they're going to go for 12 hours without recharging the batteries. So their batteries have to last them for only half a day. Other boaters with generators, I had one in the booth today, said to me, Jeff, I want to be able to last, it's a 60-foot boat, I want to last for 2 days without running my generator. I don't like running my generator. Most of my friends are sailboaters, and I don't like the noise. I like to go in quiet anchorages. I feel guilty when I run the generator. So how can I go there and I want to run it just for every other day I'll run my generator. Some people like to run, I had a client, I gave him an example. I have one power boater said, I want to run every 7 days. I want power for 7 days, and I want to run my generator for 2 hours. And then I'll run it another week later, right? So all of those variables come into play, and you've got to figure out what do you want. Now, obviously, there's a cost to all of this, but figure what you really need and what you want are two different things. So usable battery capacity is a number. And then this is where it gets crazy, is it depending on the battery bank that you actually choose to buy. Now, I'm not going to talk about lithium here because it's an outlier. Not that we don't do it, but it's not for everyone, and it's very expensive. If you go with lead acid batteries come in different flavors: flooded, AGM, gel, or Oasis AGM. AGM gel, AGM stands for absorbed glass mat battery. Gel is gel. And they're both seal valve regulated batteries. You might have heard those words. That's kind of the family. They're all lead acid batteries. One, the electrolyte is completely loose. It's flooded. You got to top it off, right, with distilled water. It boils. And then you have AGM and gel, which are actually like, you could literally drill a hole through the battery and nothing would leak. The electrolyte is like almost like Jello, but even more dense. All these batteries have what are called different depth of discharge floor. Now, what the hell does that mean? What that means is that the battery will give you a reasonable life cycle at a reasonable depth. A flooded battery, for example, the floor is 50%. So even though you have maybe 200 amp hours or 100 amp hours in that battery, you can never deplete it below 50. Now you can if you don't value money and you don't mind changing your batteries every year or every 2 years, or you're stubborn and you don't change it every year, but you pretend you still have a battery, but it never works. And that's generally what happens, is they last a season, and then you're kind of holding on, and then it never works, but you're like, no, it's fine. And then after 2 years, you're like, okay, I got to do it. And then you repeat. But if you value money and you value your time, you're never going to want to bring your batteries below 50% for a flooded lead acid battery. Now, AGM and gel can go down to 30%, so that's from 100% to 30%. So you've got more range. You can go deeper, right? So you can harness more energy out of that battery and have the same number of cycles as a flooded battery. And then there's a later battery that's been out for about 12 years, which is the Firefly AGM. That battery gives you from 100% to 20%. So that's 80% of the battery that's available. That's a pretty deep tank when you think about it. And that battery will give you 1,200 cycles. So what's 1,200 cycles, you say? A flooded lead acid battery should give you 5 to 7 years, on average. There's outliers. Like my battery bank lasted 10, but I loved it, took care of it, nurtured it. I was a complete geek. Most people are not going to do that. So most people get between 5 and 7. A Firefly AGM is going to give you 3,600 cycles. So it would last 12 times longer than a flooded lead acid battery bank. Now, obviously, the price, and we'll talk about that, the price is going to be different. And so this is sort of a table. By the way, all this presentation is going to be posted on our media page on our website, Pacific Yacht, pysystems.ca. There's a media, and then we're going to have all of this as a PDF. So you can download it. It's going to be up there on the web for everyone to download. So this is just sort of a table. When you're going to be shopping for a battery, you're going to be asking yourself, which battery is right for me? Like, you've got a budget, you might have space limitations. You might not have that much space on your boat, or you might have a lot, and you want to have more battery capacity. One of the choices, you're pretty much going to be choosing between these 3 sorts of batteries. Gel's not there because it's really finicky, and honestly, it's more than just changing a battery. You've got to change a lot of things when you put a gel battery. But it's a great battery, but it's really finicky. So you go down and you're going to be looking at the different prices, right? And you can see the dollar sign is $1. So if you buy something for 100, a Firefly is going to be between probably 3 times, 4 times the price of a flooded battery. But the big difference is that the depth of discharge gives you more usable battery capacity. So you effectively, for example, in our booth upstairs, we have a pyramid, and you can actually have 6 flooded golf carts, let's say, or Group 31, and you can replace 6 of those batteries with only 3 batteries. Right? So you don't have to buy 1-to-1 because the battery can go deeper, right? So you can save space. I had one owner, he was a racer. He's like, I want to reduce my weight on my boat. They count in grams for racers, right? So they're like, no, this is crazy. I mean, we cut our toothbrush in half, so we don't have too many grams on board, right? So I'm saying, well, look, this battery is going to give you double the depth. They're like, oh my God, this is perfect. So because again, they reduce their batteries by a factor of 2, right? So it's a good way for them to race Vic Maui races. So this is the one way to look at your choices when you're choosing batteries. So in a nutshell, you translate all of that and you look at the ratio, and if you have a flooded battery, you're going to effectively need 3 times your usable battery capacity to actually have the battery bank that's going to last you 5 to 7 years. If you have AGM, you need twice. Remember, because all the battery's not available. You can take it, sort of like you could work 22 hours a day. You could do it, but at one point something is going to give. You're not going to be rested. You're not going to certainly make it to the life expectancy that you thought you would if you work crazy hard. Sort of like being a business owner and pushing yourself too hard. So, you know a little bit about that. And so with flooded batteries, you can go factor of 3 AGM, factor of 2, Firefly AGM, factor of 1.5. So you don't need to buy as much batteries if you're going to go down with a more expensive batteries. So you're trading off price with depth of discharge. This is a little bit of demo. This is, for example, L16 batteries. And what I'm trying to emphasize there, when you're going to be wiring your house bank, what you're going to want to do is you're going to want to wire your battery bank so that you have even discharge. So you want all the loads to be at opposite ends. So you have the positive on one side, the negative on the other. Now, obviously, if you have only one battery, that's obvious. There's only 2 posts on a battery. But some of us have more than one battery, right? Our battery banks are made of 2 batteries, 3 batteries, 4 batteries. I have a client that we're making a battery bank out of 24 batteries. He could start tapping in multiple places, right? Because at the end of the day, if they're just in parallel, that's 24 posts that you could put 12 volts from. But you always want to gather power at the opposite ends so that all the batteries have to support that load, okay? The other thing I'm trying to emphasize there, and that's a common thing with flooded batteries, so a big part of our business is we do what are called electrical audits. And why that's great is I get to go on about, besides the 700 boats that we do, I do about 300 boats a year for electrical audits. Sort of like a surveyor, but just specific for electrical. And when I get on a boat, often I see a lot of water on top of a battery. The engine room is dry. Everything is dry in the engine room, but there's moisture on top of the battery. That's not moisture, that's sulfuric acid. That sulfuric acid has vented through the vent caps and is an indication that either the battery has been overfilled, or that the battery is being overcharged, or that the battery is aging and has higher resistance, and as it gets charged, it heats up, and the electrolyte, as it heats up, expands. We know that, hot air, right? And then what happens is it actually comes out through the vent caps. It will never evaporate, come down in the bottom of the battery box. And unfortunately, for about half of you, probably even higher, 60, 65%, the battery box has holes in the bottom because the battery box didn't come with an instruction manual. And even if it did, no self-respecting man would ever read instructions because they're all innate with knowledge. And so they drill 4 holes in the bottom of the battery box to hold it into place because that's the easiest thing to do. And then they defeat the whole purpose of a battery box because they didn't read, because again, why would you read when you know everything? And so then the holes are there in the battery box, which is supposed to be a container. Should be called a battery container. That would be a really good thing. Container would be really more symbolic of the real purpose of the battery box. And then the sulfuric acid eats the stainless steel screws that you put in the bottom, goes right through it. And then the screw goes into at one point, some sort of wood. And the wood is porous. So the wood actually sucks a liquid in all directions. The sulfuric acid destroys the cellulose matter in the wood, so it makes it removes its rigidity. So then you have sulfuric acid stuck in between 2 sandwiches of fiberglass and gel coat. And then you ask yourself, why, oh why did I ever buy a boat? Because now you've got to cut all that stuff out. You got to re-glass it all over again. And all because there's some holes in the bottom of the battery box. So details matter. They really do.
Does that acid damage the bottom of the battery if there is something?
No, because it's plastic. That's a great thing. Plastic is kind of innate, nothing will happen. The problem with the boat is it's a container. You know, when your battery in your car leaks, it goes on the asphalt. It's the neighbor's cat's problem. It's someone else's problem. It's not your problem. But remember, your boat is a container, right? And sulfuric acid does not evaporate. It will stay there forever until it is neutralized with a base, right? Water only dilutes it. You need a base. Water is not a neutralizer. So like baking soda. So I had owners that they lost keel boats on their sailboat. 2 aft keel boats were gone, completely devoured by sulfuric acid. So this is a big deal. So you need to make sure that your batteries are in a container, not a box. And the container needs to be completely leak-proof, and it can be a tray, right? Because boats are not on land. They move, and they unfortunately go sometimes a little bit to the side. Maybe not what you want, and you accelerate, you decelerate. If you've got water in a tray, try to keep a water glass on your boat full for the duration of your trip. It's not going to happen. Your boat's going to heel over. Something's going to happen. There's going to be a wave. There's going to be this obnoxious power boat that's coming in at like 15 knots in, I don't know, in a channel up in Desolation Sound, and the wake is like 4 feet, and your boat is going to go, and he doesn't care. He's going fast. It's not his problem. It's your problem. So make sure you don't have battery trays, but battery boxes. Let's call them battery containers. Never, ever, ever have your battery plates exposed. When you buy a flooded lead acid battery, what you're doing is you are buying not a binding contract with that battery, that under no circumstances, regardless of your life situation, it doesn't care if your daughter's getting married, if you got sick, if you got on a holiday, you went on a sabbatical, whatever your life events are, if you do not maintain that battery, and you have to top it off, that's why it's a flooded lead acid battery, once the plates get exposed, that battery is toast. There is no saving it back. You are then a losing battle. The battery is going to, now every time you charge it, it's going to boil over. So you're going to be constantly trying to keep up with a sinking ship. So you can never, ever, ever have the battery plates exposed. And if you do, the longer they are, look at that, they actually buckled. This is the inside of a battery. The plates are not supposed to touch one another. I mean, that's what it is. They're supposed to be all separated from one another. The plates actually buckled and warped because there was no electrolyte in between the plates. So when it comes to buying a battery, one question that I get asked all the time, and there's, by the way, no such thing as a bad question. People say to me, Jeff, I have golf carts on my boat. I can't have AGM. AGMs are not, they're a battery chemistry. They're not a size. First of all, when you buy a battery, you can buy a battery in all different sizes. The marine battery world, there's more battery sizes. There's probably like 50, 100 known dimensions. You can buy a Group 24, a 27, a 31, a golf cart, an L16, a slimline, a 4D, an 8D, right? All of these are known battery dimensions that manufacturers have agreed that a golf cart from East Bendeca, or a golf cart from US Battery, or a golf cart from wherever it is, it could be China, everyone is going to make the same battery dimension so that you can take one from one manufacturer and you can take and they'll all fit the same battery box. So that's good, right? Because it's standard. It's like a 2x4. 2x4 is, well, it's not a 2x4, but it's the same size for every manufacturer, and everyone has settled on that size. And that's the format, and everyone builds to that. So that's the good news. And then the next thing when you buy a battery, once you figured out the size you want, is you're going to decide, okay, what sort of battery lead acid chemistry do I want? Do I want flooded? Do I want gel? Do I want AGM or fly AGM? And remember, when it's time to buy a flooded battery, and this is very important, you have really 3 choices. You either buy a deep cycle battery, a starter battery, or a dual purpose battery. I advise people to never buy dual purpose, sort of like a all-season tire, where there's real winters. Nobody does it. You'd be crazy. Maybe here, because we don't really have one, but out east, nobody has an all-winter tire, all-season tire. They either choose a summer tire, so you start an engine with a cranking battery, you run your house batteries on a deep cycle battery. And you never, ever, black and white, ever want to run your starting battery to run your house loads. If you do, and you do it unintentionally, or you, unbeknownst to you, the past owner decided to cheap out because a starter battery looks the same as a deep cycle battery, but it's maybe about 2/3 the price or half the price, you might be one of those unlucky boaters that we get called out about a dozen times a year, where the battery actually explodes. And when it explodes, it's not just a firecracker, it's like a full-blown explosion. On one boat, it actually exploded the hatch on the back deck off the hinges while they were motoring up the river to get service for their yearly maintenance in Shelter Island. And what the owner didn't know is that when they bought the boat, the broker, to save money for the seller, replaced the dead batteries with starter batteries because they were less money, right? going to get you a deal, I'm going to save you $100, yo, you're going to be all good, it doesn't matter, it's a battery, I know everything, what's the big deal? After a year of use, right, generally it happens after a year, the batteries are so warped and they boil over so fast that there's all this hydrogen buildup in the battery. The plates warp, they touch, creates a spark full of hydrogen, and the battery explodes. And it just doesn't explode, it explodes the battery box, whatever, it doesn't matter, the strap on top, that explodes. And then the worst part is then it's exploding, but it's sulfuric acid inside the battery. So now you have an engine room full of sulfuric acid. So can you imagine? That is called a nightmare scenario. Like if you're gonna do anything in an engine room, salt water in an engine room is a problem. Having sulfuric acid over metal parts in your engine room is just, and remember, this is not a wall, right? An engine room is full of nooks and crannies and these hard to access places. So make sure that if you have a boat and you've bought it recently and you haven't changed the batteries, look in and look at the sticker. And if you have flooded lead acid batteries, a lot of you don't realize that your deep cycle batteries are actually flooded starter batteries that were less expensive to purchase at a battery place. So I may mention this earlier, and I probably sell and I emphasize this to pretty much every boater that leaves the dock, because most boaters don't boat, so it doesn't matter for most of them. But people that actually leave the dock and go boating, and they go off the dock, you'll need some sort of compass, some sort of gauge, some sort of way to know where you are electrically, right? And it's sort of the way I describe it as a fuel gauge or a speedometer for your batteries. What that means is you want to know what is your battery level without guessing, and a volt is not an indication of capacity. It's only an indication when the battery has neither been charged or discharged for 24 hours. So that never happens on the boat because you're using the boat while you're on it and the batteries are being used. So it's just a crude indication of capacity. A battery monitor will give you a relatively accurate, plus or minus a couple points on the capacity of your battery. They're about $250 to $400. $250 is actually a really good price. And it will tell you exactly what's happening in the batteries, and there's no more guessing. You'll be able to know, like, oh, we're at 50%, I'm at 90%, I'm at 20%. And then you can start making changes. Do we move today? Do we move tomorrow? Do we go back to shore power? Do we shut off a load? Can we run the inverter? Should we run the TV? Because you got to start sort of like having money in your wallet, right? You start making decisions based on, can I spend more or should I start saving? Should I stop maybe keeping the lights on longer than I need to, right? Because I want to stay in this anchorage for longer. So once you've figured out your batteries, and to recap, you need to figure out how much you're going to use a day. If you don't have a sense, I've got a pretty good sense. You describe your boat and what you do, I can give you a number that's pretty accurate. Then you got to figure out how long are you going to be at that anchor for before you get a charge. Are you a sailor that's going to take 3 days in an anchorage? Do you move every day when you go to Alaska? If you go to Alaska, do you move 8 hours a day every day? You've got a slow trawler, a sailboat? Or do you only have a tiara and you only do half an hour every 3 days? So all those factors come into play, and then we can size the battery bank, choose the chemistry we want to maybe minimize the battery bank size, or say, oh, I got lots of space, I don't care, I'll go flooded. But all of that is good, but up to a certain point, it's like giving someone money. Giving someone money is okay, but at one point, someone needs to make money. They need to know, how am I going to recharge that battery bank without being connected? Either you can be connected to shore power, or there's other ways. But some of us like to boat and go in the Gulf Islands, and not everyone wants to plug into the dock every night. The ones that do, it's a lot easier, by the way, right? And that's what the rest of North America does. California, if you leave the dock, you're going back to the dock. There is no way to go other than a dock or Catalina Island. That's it. The whole coast is empty. You go out and you come back. But in British Columbia, like Maine, or people in the Caribbean, there are destinations to go to where you can anchor safely at night, and you can do it night after night after night. And that's where it becomes a challenge, because how are you going to recharge your batteries without reconnecting to shore power? So with a charger, you always want your battery bank to be charged at a minimum capacity of 10%. 10% of your charger is sized at 10% of your battery bank capacity. For instance, If you have 4 golf cart batteries on your boat, which is a common number, that's going to be roughly non-marketing terms, so not really what the battery says, but reality, 400 amp hours. The marketing is going to say 460, but they're all exaggerating, so let's call it 400 for math. Your minimum charge rate for 4 golf cart batteries in a 12-volt configuration is going to be 10% of 400, so 40 amp charger. Now, I cannot stress this enough. When your builder built your boat, and most of us do not have a boat that was built in 2018. When they built your boat in 1975, in 1980, 1990, 2000, 2005, 2010, they sized the charger for the battery bank that was put on the boat. Nobody in the boating business gives you something you don't need at the time of purchase so that one day an owner 20 years down the road is going to be able to upsize the batteries without changing something else. When they create a system, when an engineer designs an electrical system for you, they design it based on what they give you when the boat was sold. For instance, I had an owner, Grand Banks 42, had a 20 amp charger on board and had a 1200 amp hour battery bank. Now that's sort of having an account, or call it a $1,200 credit card, and you can only deposit $20 into it an hour. But remember, when you're using your boat, you have loads, or sort of incomes isn't savings, right? I mean, none of us just save what we make. We have to spend money at a given time. So refrigeration, lights. That owner was netting about 5 amps. He had to leave the boat at the dock for a week to not be on it, close down the refrigeration to recharge his battery bank, then get back on board, then use it, then get off the boat so that he could recharge his batteries. Not understanding that his limitation was this charger was built for the smallest battery banks. So when you change the size of your battery bank, you're going to unfortunately have to look at, is my charger size or capable of recharging that battery? Now, it's not just a question of time. Time is, you might say, Jeff, I have oodles of time. Time for me is no problem. If it takes a week, it takes a week. But here's the catch. If you don't charge the rate at the right rate of charge under bulk, at minimum 10%, your battery life is going to be seriously affected and diminished. Because the bulk rate, that maximum rate, is what actually re-energizes most of the battery. So you might recharge at a small rate and think, well, what's 10 amps for 10 hours or 1 amp for 100 hours? They're both 100. What's the big deal? It takes just a little bit longer. In an extreme example, the battery bank might charge only back to, let's say, 99%. The next time you charge it, it's not 99 of 100, it's 99 of 99. And then the next time, so that's 98.1. The next time you charge it, it's 99 of 98.1. So it's basically a fraction of a fraction of a fraction of a fraction. And your battery life is going to have a slow, perfect death. It's not sudden. It's not off a cliff. It's not like a perfect battery, then it was a terrible battery. It's like it started great, and every day it just got worse. And it lasted only 1.5 years or 2 years. So your charge rate is going to maximize your battery investment. That's why you need to have a battery bank that is, or a battery bank charger that is 10% of your house battery capacity.
Just your house or combined?
No, house, because the question is, should I worry about my cranking batteries? Cranking batteries, if they're used for cranking purposes, are only going to go from 100 to 99%. Right? They'll never go into deep cycle discharge. So really the one you worry about is your house batteries. Those are the ones that are going to be brought down to 50%, 70%, 30%, 20%. And under bulk, that's when you need that minimum of 10% of capacity. You don't have to have it, but if you value money and you don't like changing your batteries, because remember, batteries are heavy, they're awkward. It's not like picking up 60 pounds off this table and moving it sideways, no problem. Picking up 60 pounds, your back bend in an engine room sideways beside an engine, and some batteries weigh 120 pounds, some are 160 pounds. That starts to be like a life event type of situation. 160 pounds over an engine room at an angle, it's sort of a thing that you'll never forget. And then they're in the engine room, right? And then you got to get them up the stairs, then off the boat, onto a ramp, up the dock, because you're probably going to do it coincidentally at low tide. it's going to be one of those things you're going to be like, yeah, I did it. I remember forever now. And I'm never doing that again. So we talked about charge rate. We talked about batteries, what's going to be the chemistry of the battery, the depth of discharge of the battery, all these variables. But how are you going to recharge the batteries on your boat? Well, luckily today there's, in the past, there was only one way. It was an alternator, right? You needed the engine to literally be on and turning. You didn't need to be connected to shore power. Some people think an alternator needs to be powered to AC. An alternator is a mechanically driven device through the rotation of the engine that creates DC power to recharge your batteries. It's DC. Sort of like our cars. The air conditioning in a car, our radio, our headlights, all the stereo, everything in your car is powered effectively, not by the battery, it's the alternator. The alternator really creates the power, and that's why the voltage is 14.4 on a car, not 12. It's a 12-volt battery, but effectively the alternator is giving you as much power as you need, constantly meeting demand. So when you're connected to shore power, you're going to want to have what's called a smart battery charger. Boats built in 70s and 80s and 90s, early 90s, have what are called ferro-resonant chargers. In case you're wondering what that is, if it looks like from the 70s, meaning if it's really, really, I'm going to use the word ugly, meaning it was built and designed by an engineer, right, where there was no other input, the opposite of Apple, for example. Apple is a balance between designers and engineers, and I'm an engineer, but let's be honest, they don't make always the most beautiful things. If it looks like it's from an era where engineers were let run wild and they did everything, your charger is a ferro-resonant charger. If it's a modern charger, it's going to have some sort of aesthetic element to it, and that's going to mean it's going to be past the 1990s. And that's how you can easily tell if your charger is outdated. And if your charger is outdated, it's the type of charger that you cannot leave on your boat 24/7. So a lot of the old timers, and I meet them all the time, they say, oh, you can't leave a battery charger on. First of all, they're using the word converter, because a lot of the old panels, it's actually converter. So it's the opposite of an inverter. And they say, yeah, you can't leave a charger on, it's going to boil the batteries. And they're right. But they were right 30 years ago. Modern chargers can be left on 24/7. My battery charger on my boat is on every time I'm connected to shore power. It's on right now. Could be on for 3 weeks, 4 weeks, could be left on for a year, could be left on for 7 years. It will never boil a battery. But if you have a ferro-resonant charger and you forget to turn it off, it's a very expensive mistake. And generally as we get older, we forget simple things. And I can tell you, I have met so many owners that are so angry of themselves that they left the boat before turning the converter on. They went down for a day, turned it on, did a bunch of things, left the boat but forgot to turn it off. They come back a week later, 2 weeks later, the batteries are completely cooked, they're boiled over, and then that costs them 8 batteries at $150 a battery. It's a $1,200 kind of, oh man. So what I emphasize to owners is, sometimes we forget things, and it's really hard to maybe always remember to turn off the converter. So consider a smart charger. A charger can be left forever, and it will adjust the voltage depending on the state of the batteries. Yeah, some owners, if you were wondering earlier, I said, how some owners are actually saying, well, I want to reduce my charge time. Like my boat owner that was saying, Jeff, I want to run my charger only every 2 days, but they have massive battery banks. You can actually add multiple chargers on your boat to reduce your charge time. On my boat, I have 6 solar panels, a methanol fuel cell, an alternator, a charger, and they can all be, and an alternator, 10 devices that can charge my batteries, and they can all be running concurrently, and they're not fighting one another. Fighting one another, and many people believe that that's also something that happened with internal regulators on alternators 30 years ago. So things change. So adages that were completely true before, they were not misinformed, they were right. When the technology changes, those old adages unfortunately don't hold water anymore. So you can definitely have multiple charge sources on a boat. Many owners, we do a lot of solar, many owners will have solar panels connected to their batteries while their engine is running. It's not unusual, it happens. The sun's out, they're using their boat in the daytime. If it's sunny, they're both charging the batteries at the same time. And so there's ways to reduce your charge time by having multiple charge sources on your batteries. So talked a little bit briefly about an alternator. You know, remember an alternator only works when your engine is actually turning. Not the key on, but actually the rotation of the engine is actually turning. And the other thing that's really essential is the output of an alternator is actually directly influenced by the rotation of the engine. Meaning if you have your engine and you start an engine, you have a diesel engine and you're idling at 800 RPM, the output at 800 RPM is not the same output at 2400 RPM. It's a function of the rate of turn of the engine. So you will have higher output at 2400 RPM than at 800. And I don't mean like 1 or 2 amps, it could be multiples of. At 800 amp RPM, your alternator might be only giving you 10, 15 amps. And at 24, it might give you 50, 60 amps. So running an engine at idle, or 1100 or 1000 RPM, is going to severely affect the output of your alternator.
For the rating on an alternator.
That, yeah, I'll talk about that. So here's, and that's in the next slide. So here's the disconcerting part, and that's unfortunately the fact with marketing, is that nothing is ever what it seems. It's a reality. So you got a stock 55 amp alternator with an internal regulator. First of all, bad news is that rating is when it's cold, meaning it's only for the first 15 minutes that it operates. The moment it gets hot, it's going to be derated by 15%. So you'll never see 55 amps out of an alternator for many reasons, one of which is the moment it gets hot, it's going to be derated by 15%. The other reality is that the internal regulator at the back of the alternator is pretty dumb. It's cheap, it costs almost nothing. And that thing is going to, for safety's sake, is going to deregulate the alternator by another 2/3. And then to make matters worse, it's also sensing voltage at the back of the alternator, not at the batteries. And the batteries are what need the voltage, not the alternator. And there's a difference between the two, even though they're connected. And so your effective charge rate of a 55 amp alternator, assuming you're at reasonable cruising speed, like 21, 23, 2400, 2500 RPM, not 1400 RPM, because you have a trawler and you don't like to burn gas or diesel. You're at about 30, 35 amps. Now, 30, 35 amps is not what you put in the batteries. You're running loads at the time. You might have your chart plotter on, you might have your radar, you might have the heater on, your fridge is running. Loads are happening when you're running your boat. So imagine what you're actually netting in terms of savings. I've come on brand new boats, $1 million boats, that while the engine is running, they're drawing more power than the alternator is creating. I had an owner that if he could never make it, this is amazing, he could never make it to Smugglers without the engines dying. The engines would die because they're powered by modern engines, electrical controls. The batteries would die because the engines would, everything on the boat would draw more power than the alternators would create. The furthest he would go is about Seashell, and then the engines would die. It's amazing. $2 million boat, I'm not joking. I would be so frustrated. I'd be like, what the hell? So we came on board and we measured, and the amps were crazy. To run that ship was so amazing, and he had the tiniest alternator. So we put a huge beef, I mean, it's 60-foot boat, so he can have a big alternator. Put 200-300 amps alternators, problem solved. He actually, as a short-term measure, had to run his generator to run his boat. Not joking. So, at the end of the day, remember, what you earn is not necessarily what you save. I mean, we all know that in our personal life, right? Otherwise, life would be so easy. I mean, it'd be amazing. So, you got to think about what are you netting and what RPM are you actually running your engine at, right? Yes?
Could you say something about the notion of combining the output from two alternators, the device required to do it?
Yeah, that's called an automatic combiner relay. So there's ways of putting, if you've got dual engines and you want to have one engine is just recharging your engine battery, the other engine's doing your house, there's ways of running them in parallel automatically through a device that's called either, and these are marketing terms, VSR, voltage sense relay, ACR, automatic combiner relay. Ultimately, they're just solenoids, digital solenoids that are closed, i.e. they let current from one battery bank to the other whenever they sense a charging voltage. It's sort of like, it's easy for Bill Gates to give 20 billion to charity when he's got 56. So the alternator goes, or the ACR goes, hey, listen, when there's times of plenty, let's share. When things go rough, each on its own, right? Everyone on its own. And they do that automatically. It's sort of the version of using a battery switch. And when the engine is running, you go to combine, but then when the engine is not running, you go back to off. Some people forget to go back to off. The next morning, they'll start the engine. Doesn't start. They go to 1, doesn't start. They go to 2, doesn't start. They go to all, that doesn't start. They realize, oh crap, I left the battery switch on all, and now all my batteries and banks are depleted. And then there's no backup. So that's the reason ACRs and VSRs were invented. They're basically digital solenoids. So in case, and I had this conversation, we probably do about 200 of these a year, are what are called external regulators. It's basically a device that says to your alternator, I want you to be smart and I want you to recharge my batteries. And I can put one of those on an alternator and I will actually get the hot rating of the alternator. Meaning if I have a 120 amp alternator, I can get pretty much like 105 out of that alternator with this device. Tiaras, for example, because it's a boat that goes fast and gets somewhere quickly, I'll have them stock on the boat. A lot of sailboaters, it's a desired thing because ideally, not here, sailors sail. And so they like to run their engines for a short period of time and then start sailing. But in the summer, as we know here, there's no wind, so most of them are just power boats with masts. So really popular device. I'm a sailor, by the way, but let's be honest. The next thing that you can consider, and I have one in the booth running right now, is a methanol fuel cell. I sold like 6 yesterday. It's a little generator about this big, this high. And what it does is it basically allows you to have a DC charger, right? A charger powered by methanol to recharge your battery banks. I have a lot of owners that have troublesome generators, or they have a trawler, they don't want to put a generator. A generator is a big ticket item. It's like a big boat buck. Big boat buck is like 10K. That's a real dollar, right, in boat terms. Might be like 10, 20, and they're like, no, that's just too much money. I don't want the noise, I don't want vibration, where I'm going to mount it, I don't have the space. So what some boat owners are doing is they either have a genset, they don't have a genset. I had a client this morning, Silverton, doesn't have a generator, but he doesn't use a TV, he's really modest, but he wants to be able to stay at anchor and not have to run the engine to recharge the batteries. So a methanol fuel cell is a charger that runs off methanol fuel. And the methanol fuel is about this big. You'll use maybe 1 to 3 of those jugs in the summer. Makes no noise, no smoke, no vibration. You put it under a bed, doesn't matter. And so that's a really popular option. If you want to see one running, there's one in the booth.
What does something like that cost?
It starts from $3,500 to $7,000. It's not for everyone. It's really if you've done everything and then you're still not having what you need, this is sort of like your last option. And then lastly, before just a couple minutes, I just want to emphasize, and you'll see that upstairs too in our booth, 322 by the way, is flexible solar panels. And I did my boat 5.5 years ago. I was the first one in British Columbia to have flexible solar panels. And I did an array that allows me to be completely power neutral from the grid for 5 months of the year. Meaning from May to September, I don't have to plug in and I can have my refrigeration. I could stay at anchor for 5 months. You can't, you need food. And you need to, stuff, water. But I don't have to plug in at the dock or anything from solar panels. And some owners are extending their day from 2 days at anchor to 3 days at anchor. And they're extending their stay at anchor with solar power. So we've probably done about 300 boats with solar panels. We have probably 50 some panels, well not 50, about 20 upstairs, but 50 in total. And there's a different panel for every boater, different price points. We have 6 different lines. And so you can choose. You want Chinese made, German, Italian, all different flavors. In British Columbia, in the summer, in June and July and August, the sun shines so long, and it's actually sunny here, unlike the East Coast. If you have friends on the East Coast, they can tell you how bad their summers are. The sun shines here in the summer that you can actually get a quantifiable difference where you can actually be neutral or do what you wanted to do via solar panels. It's not a gimmick, and it actually does work. So on that note, it's about 3:57. I'm going to let it go. There's a next talker. If you have questions, I'm doing a DIY, electrical connections, down over, how to do electric crimps on wires. I've got one of my electricians that's going to be showing that, showing the importance of how to do connections and how to do it safely. So that's going to be in the room. And after that, if you've got questions, you can see me upstairs in the booth 322. I want to thank everyone for taking the time to be here with us today. and enjoy the boat show.